Algebra 2, when you're finding the zeros of polynomials, the easiest way known to man to do that was via synthetic division, where you were dividing by the zero of some term synthetically into a function to see if it equaled 0 at the end. Basically, it didn't have a remainder, if you remember that. When we did stuff like this, we had to talk about, well, how do you have zeros? What do they mean? Where do they come from? How many do you wind up having? Things like that. So comes out with a couple of different theorems that you guys may or may not remember. Let me just ask you this before we get into that. If I have a fourth degree polynomial, how many possible total zeros could I have? 4. That means I could have 4 possible zeros. Is it likely I'm going to have all 4? Can I have just 1? Can I have none? It's all possible. Okay. Now, we also dealt, that's where we had those imaginary roots and things like that. That was basically what we called the fundamental theorem of algebra. You don't have to know it by name, but you know how to use it. If you have a 4th degree polynomial, you can have up to 4 total zeros. If you have a 3rd degree polynomial, you would have up to 3 possibles. If you have a singular degree polynomial, you could have 1 zero. That's all that meant, guys. And you've been doing that since day 1 when you first used this. Because it crossed the y-axis. It crossed the x-axis. The only time it didn't cross the x-axis was when it was y equal to a number that wasn't equal to 0. So, you guys all have done that. All right, so this isn't anything crazy. You've also did this, but you didn't know that this is what it was called, linear factorization. But if I showed you this, f of x equals x squared minus 6x plus 9, how do I factor that? -3, -3. So it's x minus 3, x minus 3. So this is what you've been doing all along for factor. It just looks weird. Remember, and so on and so on, and so on and so on for however many possible zeros you have. Oh, that's all that meant. Okay. Pre-calc book likes to be over technical. What I'm trying to show you guys here is that you've done everything in this section. You just haven't done it via the ways that they have written it. Now, what they're writing it out here is called linear factors. Each one of these is its own linear factor because x minus 3, if I set it equal to a function, would be y equals x minus 3. It's a line. Dun, dun, dun. Linear function because it has a degree of 1. Everything we write out, we can write it out in terms of factors with degree of 1. Whether or not they wind up being imaginary solutions or real solutions, you can still do that. And each and every one of you guys have done that. For example, if you did that with f of x equals, we'll make it really easy, x squared plus 4. I can't factor that, can I?
You could.
No, it has to be I.
What are my 2 zeros?
Plus or minus 2.
Plus minus 2i.
Plus or minus 2i. My zeros here wind up being x equals plus or minus 2i when I solved that. Which meant that there are separate terms. And we'll get into, you've done this part, but by tomorrow and Monday, we're going to be able to come up with the actual terms themselves that have zeros of plus or minus 2i by writing out in terms of the conjugates. Okay? Yes?
Yeah.
Yeah. Okay. So, I do have more than one, yes.
So like why is
Yes.
there a
X
bird?
equals plus or minus I.
He's telling us to get back on top.
Thank you. Anyway, so like we've done this, and I don't want you guys to write any of this stuff down, but I just want to show you that you've done all of this. When we did that first example where we had x squared minus 6x plus 9, we had two terms, x minus 3, where it had a multiplicity. It was a repeated 0 at 3. It was repeated twice. Third degree polynomials, you can have up to 3 possible zeros. X cubed plus 4x, well this is where we got that x squared plus 4. If we factored that further in terms of the conjugate stuff, and I'll show you guys how this always works, your 3 separate terms would have been x minus 2i, x plus 2i. There's little tricks in how we write these things out later on. Fourth degree polynomial, you could have up to 4 zeros. You factor that out, you get x squared plus 1, x squared minus 1. You can factor out the x squared minus 1 further, but you can't do the plus 1. It's these little tricks, but you guys have all factored this. You've factored that. You've done all of that work before via polynomials operations with synthetic division. Okay. So let's look at how we used synthetic division. In order for us to use synthetic division, we had to use this test. It's called the rational zeros test. Remember back in Algebra 2, in Algebra 2, you guys were given a function. F of x equaled 2x to the 4th minus 3x squared plus 4x minus 6. And they were going to ask you to factor that using synthetic division and whatnot. When you're using synthetic division, if you don't know where to start, you have to use what we call that rational zeros test, where we take all the possible values of the last term. What are all the factors of 6? All the factors of 6, which we call P, 1, 2, 3, and 6. And we divide it by all the possible factors of the leading term coefficient, 1 and 2. So all the possible zeros there could have been would have been 1, 2, 3, and 6, 1/2, and 3/2. But what am I missing? Plus minus. Because you can have them with plus or minus. Okay? But hopefully you guys remember that using synthetic substitution, synthetic division was easy.
It's easy, but like it's hard to find it.
But remember, you don't have to do all of them. The worst thing came is if you had to try it more than once to find the first zero. Because a lot of times after you find that first zero, it drops it a degree, and you usually can factor it from there. I just made up a bad example here. I highly doubt we're going to find something that works clean, so I'm not even going to bother going through all of the synthetic here. But I just wanted to show you, to remind you that I know you remember this stuff because you all moaned and groaned and said, oh. Yes?
Pretty big. What's the one that you do like 2 with the exclamation point? What's that?
Factorial.
Isn't that what we're doing?
No.
Oh, good.
That's when you're yelling, 2!
Jesus, I like
I
those.
get it.
Those
I get it.
are easy. I like
Or
them.
miss
So it's
it.
boring.
Like 6 times 5 times 4.
That was when we
No, wait,
did
that was better right there. Now I get it. Sydney!
Space for Jesus.
that. What you're talking about is when we're doing the permutation combination stuff, and that's, I don't remember if pre-calc gets into the stat stuff. We might not. So let's do that with a leading term coefficient that is equal to 1, so it's a little bit easier. So we have the function f of x equals x to the 4th minus x cubed minus x squared minus 3x minus 6. And what I'm going to do here is I'm going to list out all of my possible zeros so I can start factoring via synthetic division. Okay? In this case here, the leading term coefficient is 1, so no matter what, I'm only dividing by 1, so I don't have to do anything there. Yay! I just list out all my possible factors of 6. Plus or minus 1, 2, 3, and 6. Which means there are 8 possible things that I'd have to try to to factor. But remember,
Wait, where'd you look?
what are all my factors of 6?
Oh.
1 times 6, 2 times 3,
Yeah,
1, 2, 3,
Yeah.
and 6.
so like, what does that one?
Oh, the leading term, I'm sorry, I thought you were talking about this one. This is just mean that the leading term coefficient was 1. Because if this was 4, I'd have to divide all these by 1, 2, and 4. Since it's 1, I don't have to do it.
Okay.
You take the tail, the possible factors of the tail divided by the possible factors of the front.
Okay.
Synthetic substitution, excuse me, synthetic division, remember it was that sideways, backwards L.
Yeah.
And then all you have to do is pluck out your coefficients. Take out all your coefficients. You have 1, negative 1, 1, negative 3, and negative 6. And now it's just fast.
Negative one.
You said negative 1 works? Okay. I'm going to use 1 real fast just to remind everybody how it works, and then it will go on from there. I just start at 1. When you're using synthetic division, remember the rule was you always drop the first term, multiply on the outside, add inside, multiply on the outside, add, multiply, and I did not get 0 to end. If I didn't get 0 to end, that meant that 1 is not a 0. And then I go through it again. Yep.
Okay.
Then I just go back and restart. And I check it with negative 1. Drop the 1 again. Negative 1 and 1 is negative 1, negative 2, 2, 3, negative 3, negative 6, positive 6, and 0. That means negative 1 is a 0. If negative 1 is the 0, what's its term? Excellent. That means that negative 1 is a 0, so its term is x plus 1. So I know that x plus 1 is one of the factors of that x to the 4th and so on and so on.
There's always going to be more than one factor.
If it's 4th degree, you can have up to 4 factors. Okay.
Yeah.
Now, the other thing that happens is every time you synthetically divide and you get a 0, your degree drops by 1. So now I have x cubed minus 2x squared plus 3x minus 6. And you might be pleasantly surprised that you can group that. Do you have to? No. Can you continually synthetic divide if you want? Sure. But if I recognize that I have a 4-term polynomial that I can get GCFs and group, I'm going to factor it via grouping.
Oh.
Because it's quicker. GCF is x squared, x minus 2. GCF here is 3, x minus 2. Which means my terms will be x plus 1, x minus 2, and x squared plus 3.
You could have did that first.
What do you mean?
You just, all you did was just, oh. I don't know, where'd you get the x to the third one?
After I synthetically divided and I had 0 at the end,
Oh, okay.
that meant that this went down a degree and it went through. So that means now you've got your 4 possible zeros you can get. I have negative 1, 2, and what does this one become?
3 over 2.
Plus or minus I root 3. It's I root 3, guys, because when you set that equal to 0, you get x squared equals negative 3. Square rooted, you get plus or minus I root 3. Okay? And that's what synthetic substitution and synthetic division allows you to do. Factor higher degree polynomials
Where
quickly.
did you get x plus 1? Because we found it.
We found that negative 1 was a 0. And that's the whole relationship between zeros and terms. If 0 is negative 1, term is x plus 1. If 0 is negative 6, term is x plus 6. If the 0 is positive 7 halves, term is negative 7 halves. Things, I have no idea. Okay? Let's try another one. Let's do one with the leading term coefficient. And you always start these problems the same by listing out your possibilities. That way you just start going down the list.
The last time we
Yeah.
just did the x squared plus
When it was x squared, we wound up with, it was x squared plus 3 equals 0, so we got x squared equals negative 3, x equals square root of negative 3, so x equals plus or minus is plus or minus I root 3. Okay. So start with your list of the factors of 3. What are the possible factors of 3?
1 and 3.
1 and 3.
divided by 2.
Divided by 1 and 2. So your possibles here are going to be 1, 3, 1 half, and 3 halves, all plus or minus. And now you just start with your synthetic. Two, 3, negative 8, 3. Excuse me. Start with 1.
Whoa.
Whoa, look at that.
First try.
Woo-hoo.
Okay.
So 1 is a 0. What's the term? X minus 1. So I have a term of x minus 1. And now my other part is 2x squared plus 5x minus 3. Well, that's just a regular old boring trinomial, isn't it? What times what's negative 6? You add together to get positive 5.
6 and negative 6
Isn't it?
and, or negative 1 and 6.
So wouldn't it be what multiplies
Wait.
to negative 12?
Try it.
What multiplies to negatives?
Negative 6 multiplies to negative 6, it adds to positive 5. 6 and negative 1.
But I said it backwards.
Yeah.
That's dumb.
Sorry, it's supposed to
I jumped ahead of myself.
So you get 2x squared minus 1x plus 6x minus 3. Move this up, and then just group it again. All I'm doing is, I'm just grouping them. So my factors are x minus 1, x minus 3, and 2x minus 1.
How'd you get negative 1 and 6?
What times what's negative 6 add together to get positive 5? Negative 1, positive 6. So you got your 3 possible terms, which gives you 3 possible zeros. All 3 of these zeros are real. You get 1, 3, and 1 half. Now, could I have continued on with guessing and checking with all my synthetic to get all of those?
Is it plus
Good.
minus 1 half?
No, because I didn't take square root. I add 1 divided by 2. Make sure when you're checking your zeros, if you're doing that, Manny, make sure that you only have the same amount of zeros as you do. It's an easy way to make sure you didn't get that extra counting. All right? Okay?
No, please don't.
No, please no. Okay. We're doing.
I thought you were eating that.
Getting there.
That's a nice apple.
Thank you.
What hour do you have lunch?
4th hour. Oh,
Okay,
lucky
well,
you.
You've already ate lunch, and all of us have 10th hour, and you haven't even got to eat yet.
I eat
granola bars during the day, so maybe we should bring
Granola bars
I bring a
really are,
snack.
they don't really keep you full very long.
They don't, but it's
Cliff
better
bars
than
do.
nothing.
Yeah.
I would get granola bars every day and
You
6, 7.
know,
Let's try this.
But today I ate it.
this is a nice apple.
What do they do?
I saw her do it.
It's like a love.
No, it's not.
It's like you record your people.
No, we can't group right away.
Yep, nope, can't group right away.
Nope.
If I group that, is there a GCF that works that I'll get terms of x minus 6 on both sides?
No.
I want to. I'm so tempted. So tempted. What? No, but you can't.
Do you talk about that?
Feel it in your bones. You feel it.
Do you have a dog?
I do.
Do you talk like that to your dog?
No. I told my dog to get off the couch.
What's your dog's name?
Lucky.
Is it a golden retriever?
She's a big black lab.
Oh, I want a lab.
She's good. She's good. My possible factors of 10. 1, 2, 5, 10. Okay. List out all your possible factors of the tail, divided by all the possible factors of the leading term. Leading term happens to be 1 again, don't need to worry about it.
I think we should start with 5.
Yeah.
1, -6, 13, and -10. 1.
So close.
Ah.
So far.
-1.
Someone say so close.
Nope. Nope. It's gonna wait. We know. No.
Ah, ah, ah!
Oh.
Ding, 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 ding.
She's gonna ask for a bite.
Yeah. It is so fast for a bite.
Is if 2 is a 0, what's your term?
Not get a 10.
X plus 2. X minus 2.
Which is it?
X minus 2.
So I have x minus 2, and then I have x squared minus 4x plus 5. What times what's 5? You have to get -4.
Negative 5 and 1. Negative 5 and negative 1. Negative nothing.
Whole lot of nothing, isn't it?
Oh my.
A whole lot.
Oh my.
Now-
You have
No
to
solution.
do it again.
Yeah, no solution.
Now, let me ask, obviously there's no real solution.
Oh,
of course there is.
man.
There's some stupid imaginary maybe,
But like we don't. Not.
but what is one method that I can solve for a 0? Quadratic formula, very good. Use that quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a.
Fun song.
Well, we also killed puppies.
How did they go one more time?
That was my
So you wind up with underneath your discriminant, you get a discriminant value of -4. What is the square root of -4? Plus or minus 2i. So you wind up with 4 plus or minus 2i all over 2.
That's ugly.
What can I do? Am I do? In this case here, all 3 terms, they're all even. Everything is divisible out by 2. So you have zeros then at 2, and then 2 plus or minus I. Hmm?
How's that?
Honestly, I thought the same.
I'm sorry, guys.
Yeah, I'd say you're not sorry,
So
so.
not an apple.
Yesterday, when they came to get you, they were going home. They were to appointment.
Find all zeros, please. Find all zeros, please.
Because I'm at 3 and,
Well, it's -3.
okay, well then I still went wrong.
Wow.
Yeah.
There could be imaginary zeros now.
But I'm at 20. -3 words.
Yes, I already.
Oh, because I did 3 times 3 is 30.
And you might notice right away, aren't you going to be able to group that?
Oh.
You're going to be able to group that, so you have -3 is a 0, so your term is x plus 3. I'm hoping you guys are getting the habit of rewriting your zeros as terms, and then rewriting the secondary step through. It does help. X cubed, 3x squared, 1x, and a 3. So we have x squared, x plus 3, plus 1, x plus 3.
Whoa, whoa, whoa. Bullseye.
So we have x plus 3, x plus 3,
Okay.
x squared plus 1. So we have a multiplicity at -3.
Crap.
Well, you just have it out twice, that's all. It's just -3, -3. And then the other one's going to be at plus or minus I.
Oh, I forgot that.
Come on.
Okay?
We have to write
It's F for you.
Let's put it.
So it's, what I'd like you to get in the habit of writing it out. If you wrote it down once, it's not a big deal. Okay. You guys have that day 1 assignment. Get the day 1 done. It's mainly, I don't think there's any imaginary in day 1.
30.
Remember on 2-5, I changed it up. So 2-5, there's a day 1, which was 12 through 24 evens.
No.
The day 2 of it was the 30 through 36, 40 through 42, 48, 50, 106, and 110. This day 2 stuff might change a little bit. We might spend a little bit more time with some of the zeros that you have to worry about with imaginaries, because I don't think there's that much of them. So we might change that up a bit, but for right now, we should be all right. Okay?
Yeah.